This particular video is going to help you solve what we call linear inequalities. And we're getting ready to move into linear functions, and linear models. So solving an inequality is going to help us do these things. So an inequality is a mathematical statement that contains one of these four symbols. And unlike an equation, in order to actually solve this, we have to produce what's called a number line. So we have to graph it. And we plot the endpoint on a number line here. And we're going to shape the number line to show which numbers are solutions to the inequality. And again, let's go back to what we talked about when we talked about interval notation. And just remember that we have to talk about inclusion and exclusion. And remember that this symbol and this symbol means to exclude. And on a number line, we do that. We need an open circle. And then this symbol and this symbol means to include. And again, when we do this, this is going to be a closed circle. So we solve these just like we would any equation, except one thing we want to try to do here is we always want to try to put the variable on the left-hand side because we read right to left. So we always want to put the variable on left side. So starting here, to do that, I'm going to isolate, and it just so happens that the 5x is bigger, so I will move it to the left side to begin with. So I'll subtract 4x on both sides. I'm going to solve this just like it was an equation, right? So subtracting 4x, I get x minus 9. Keep the symbol less than or equal to, goes away, 3. Remember, to solve this, now I need to add the 9 to isolate the variable. So plus 9, and then I get x, this goes away, is less than or equal to 12. So from here, we have to draw this as a number line. I like to put 0 on my number line and then locate where 12 is, somewhere out here. And remember, looking at this symbol right here, it tells me I'm going to include the 12. I'm going to shade everything to the left of the 12. So I'll draw a closed circle of 12, and I'll just go in this direction here. And this is how we produce the solution. And remember, we can write this solution a couple ways. We can write it in interval notation. For the interval notation, this would be negative infinity to 12, or including. Or we can write it in set notation, which is x such that x is less than or equal to 12. So we can write it like this as well. Now, for the next one, again, same process. I want to put everything to one side, on the left-hand side. But before I can do that, I need to go ahead and distribute. So here's what I get. 2x minus 8 minus 5 is greater than or equal to 4x plus 12 minus 13. And remember, once we distribute, we can combine like terms. So I can combine these like terms here and these like terms here. So when I do that, I get 2x minus 13 is greater than or equal to 4x minus 1. And so I want to move everything to the left side. So what I'll do is I'll start off by subtracting 4x. So I'm going to put it on this side. The x is on this side. So here's what I get. 2x minus 4x is a negative 2x minus 13. That's greater than or equal to, this goes away, minus 1. Isolate the x. So I need to add 13 to both sides. And I get negative 2x is greater than or equal to positive 12. So solving here, divide everything by negative 2. Now the issue is that when you divide things by negatives in terms of equalities, it makes things change. And in particular, it's going to flip this sign around. Anytime we divide on both sides the variable by a negative like this, we're going to change this inequality sign. So when we do this, I get x is, instead of being greater than or equal to, is now less than or equal to negative 6. And again, this sign flipped because we divided by these negatives in the bottom down here. So when I draw my number line, Again, here's 0, here's -6. It's less than or equal, so that means I'm going to include it. I'm going to shade it to the left like this. My solution looks like this: negative infinity to -6, include our x such that x is less than or equal to -6.